Assalamualaikum warahmatullahi wabarakatuh. This is group 7 and we are going to be presenting about classification model air conditioner using fuzzy logic approach. So for our team members, we got INTAN FATIHA, AINUL AISYAH, FATIN NADIA and me, AMIRUL HAKIM.
Okay, for project introduction, fuzzy logic is a form of knowledge representation suitable for notion that cannot be defined precisely but will depend upon their context. Fuzzy logic has become an important part in our daily life, enhancing the adaptability and efficiency of various systems and technology by handling impressions and uncertainty in a way that align with human-like decision making. Uh, Fuzzy logic is frequently used in air conditioning to improve efficiency and perform by increasing the ability to adapt to changing environmental circumstances. For this project, the aspect where fuzzy logic is applied in air conditioning are temperature control and humidity regulation. So for problem statement, the problem statement is only one, which is temperature control is too complex. Where the air conditioning system is running, the temperature start to drop over time. People need to wake up in order to change the cooling temperature during the night, which is the majority of people find it challenge to wake up in the middle of the night, which is disturbed during sleep time to manually change the air conditioning cooling level to provide the air conditioning high degree intelligence. A fuzzy logic system took humidity and temperature into account was created. Next, this is the objective. First is to optimize comfort, humidity level, and temperature regulation in very environmental conditions. Second is to reduce energy waste by continuously assessing the thermal conditions and making gradual adjustment. Lastly is to consider human comfort factor in temperature control that leads to personalized and user-friendly experience. Next, I will pass to Amirul Hakim.
So for falsification, we got two input variable, which is room temperature and humidity. So for room temperature, the membership value is very cold, normal, hot, and very hot. For the membership range, we got 0, 1. For input variable, humidity, the membership value is dry, normal, quite wet, wet, and very wet. And the membership range is 0, 1.
For this specification, the output variable is AC underscore temperature in Celsius. Membership value is cold, normal, hot. Membership range is 0 and 1. For equation use, for our project, we use center of gravity, which is COG, and this is the formula. Next, I will pass to next presenter.
Okay, for the analysis and design part, this is the basic block diagram for the air conditioning. So we have two input here, which is the room temperature and humidity. Moving on to the activity, we have the falsification, fuzzy inference rules, and defuzzification. So for the output, we are producing the output for AC temperature. Next. So this is the confidence value for room temperature. We are using the range between 10 to 40, and we have the membership value for which is the very cold, normal, hot, and very hot. So for the very cold and very hot, we are using the trapezoidal graph, and for the cold, normal, and hot, we are using the triangular graph. Next. This is the confidence value for humidity. So the range is between 40 to 100, and we are using the membership value for dry, normal, quite wet, wet and very wet. So for the dry and very wet, we are using the trapezoidal graph, and for the normal, quite wet and wet, we are using the triangular graph. Next. So this is the fuzzy inference system. Next. So for the rule base, we are using the if-then rules, and we have the total of 25 rules. So we can see here that we have the input room temperature and also the humidity, and the AC temperature as the output. So for the room temperature, if the room temperature very cold and humidity is dry, then AC temperature is hot. Second rule is if room temperature is cold and humidity is dry, then AC temperature is hot. So and so on for the next rules until 25 rules. Next. Okay, next we're moving on to the MATLAB demo.
So now I will be doing the demonstration of our project in the MATLAB. So here I'm gonna type fuzzy in the command window. So it will looks like this. So it will open the fuzzy logic designer over here. So our project have two input. So over here I'm gonna add another variable for input. So there you go, have two input. So the first input we name it as room temperature, and then for the input we name it as humidity, and for the output we name it as aircon temperature as AC temperature. So all these three we using the centroid of diversification. So after that, so now we will be putting our membership. Okay, so now I will add the membership function. So we have 5 membership function in our project, so we have 5. Okay, so for the first column we're gonna put the range 10 until 40. Okay, and then for the membership function 1 we name it as a very cold. Okay, and then we use the type trapezoid type graph, and then for the value we're gonna put 10, 10, 21.4 and 23.2. so here how it gonna looks like. Okay, next for this second membership function we name it as we have cold, and then it's triangular, we use triangular, and then for the value over here we put 22, 23.5 and 25. So here how it looks like. And now I will be repeating the same thing for the membership function 3, 4 and also 5. Okay, so for the very hot we use the trapezoid types of graph, and also here is the value. So here how the graph really looks like. The same thing in the humidity part. Okay, so first we have all, and we put add membership function. We have 5 also, and okay. Okay, so over here we use the range 40 until 100. Okay, so the first membership we name it as dry, and we use it trapezoid for the types, and then for the value is 39, 40, 70, 93, and then 73.93. Okay, next for the membership function 2 we name it as normal. So we use triangular, and then for the value we choose 72.73, 75.76 and 78.79. And then I will be repeating these steps until our membership function number 5. So the very membership function is trapezoidal type. So now we will be proceed to do as AC temperature, the output. So the first column here, we're gonna put range 18 until 32. And then for the first membership function, we call it as cold, and we use trapezoid for this. And then for cold is 0, 18, 21, and 25. While membership function 2, we name it as normal, triangular, it's 24, 25, 25, 27. And then for membership 3, it's hot, we use trapezoid for this as well. Okay, here is 26, 30, 32, and 32. So here, so it's like the variables for room temperature. Here is the humidity, and let's see the AC temperature. Okay, so now we're gonna proceed to edit the rule base for our function. Okay. So now here we're gonna do the 25 rules in order to output the diversification. So for example here, we're gonna put the room temperature is very cold, humidity is dry, and AC temperature is hot. So add rules. So now I will be proceed until 25 rules. So now we done our 25 rules, and then in order to see our output, you just go to the view and see the rules. So here are the results. So here is, you can see the room temperature and humidity as the input, and the AC temperature as the output. So the diversification that we use is COG equations in order to find the center of mass. So as you can see over here, so here is the result of the COG equations. So that's all from me. I'll pass to the next presenter.
So for the conclusion, in summary, the air conditioner classification model using fuzzy logic project effectively uses fuzzy logic to classify air conditioners based on various features. This model proves useful in dealing with the uncertainties related to air conditioner characteristics. Overall, this project showcases the potential of fuzzy logic in creating practical and intelligent solutions for real-world challenges in the air conditioning sector. That's all from us. Thank you.